All right, so the first one is a tangent transformation, and you have a vertical stretch of 2. A vertical stretch. So you want to think about what your parent graph looks like, and your day 3 homework is helpful. So amplitude is the word that we use for sine and cosine, and vertical stretch works just like amplitude, but it's just not a good word if it's not sine or cosine, okay? So here's our parent graph, and what we're going to do is we're going to take this point that was at pi over 4, 1, and we're going to stretch it up to 2, okay? So I still have my asymptotes at negative pi over 2 and positive pi over 2. And if I were to graph another period of it, it would be at 3 pi over 2.
So is the midpoint always going to be in the middle for tan?
So it's always going to be in the middle unless you shift it left or right, right?
Right. And so then where would the asymptotes shift?
So when we shift a tangent left or right, then the asymptotes are built halfway to the left and halfway to the right. And I can refer you back to your warm-up for that. Let me see if I can find the warm-up. No, oh, it's on a different page. Because we did that on the warm-up. On the warm-up, we shifted the midpoint left pi over 4 in number 3, and then we built the asymptotes to the left and to the right of that. Okay?
You put it at pi over 3?
Sorry, pi over 4. Negative pi over 4 for number 3.
Okay.
Yeah. But anyway, let's go back to our problem. So for this one, normally you would have a point at pi over 4, 1, but because of the stretch of 2, it's going to be at pi over 4, 2. And then normally you would have a point at negative pi over 4, negative 1, but that's going to be at negative pi over 4, negative 2. So when you graph it, it looks pretty much like the parent function, except it's just a little bit stretched. And if you do another period of the graph, it's the same thing. Stretch it by 2. So the range for the tangents and cotangents will always be negative infinity to infinity. And the domain is going to be all real numbers. X does not equal, and you're going to keep your first asymptote at pi over 2. And then how far is it between asymptotes? Pi, yeah. So pi over 2 plus pi k. And k has to be an integer. Remember, k is an element of Z means k is an integer. All right, the next one's just the parent function for cotangent. So remember that cotangent has different asymptotes. They're at 0 and at pi. Again, you can refer back to your notes, your homework from day 3, and this is your cotangent graph. Asymptotes at 0 and at pi. And cotangent's decreasing. So here's pi over 2, pi over 4, 1, and 3 pi over 4, negative 1. And if you did another period of it, it would be here.
Is the cotangent asymptote in the middle?
So there's one at 0. Is that what you mean?
Yeah.
Yeah, there's one at 0, then the next one's at pi, then 2 pi. So the domain is all real numbers. X does not equal. How do you say all the pi's? Pi k, good. K is an integer. And then the range is still negative infinity to infinity. I think since we just did the parent graph for number 2, we should skip to number 6 so we can talk about cotangent transformation. Are you guys okay with skipping to number 6? Okay. So we know that this goes right pi over 2, and this is going to be a vertical stretch of 3. If it's cotangent, though, what do we shift first? Do we shift the midpoint or the left asymptote? Yeah, so we're going to move the left asymptote right pi over 2, so it goes here.
You mean right pi over 2?
Yeah. Sorry, did I say it wrong?
Yeah.
Thank you. It goes right pi over 2. And we didn't change our period, so how much is our period? Pi, good. So that if we start at pi over 2, to find the next one, we do pi over 2 plus pi. And you need a common denominator. So pi over 2 plus 2 pi over 2 puts our next asymptote where? 3 pi over 2. Alright, so there's a stretch of 3, and it should be decreasing, so see if you can do that. So there's your midpoint. Stretch of 3 goes up 3 and down 3. Okay. Anybody want to take a stab at domain? Adam, in the bag. All right, x does not equal the first asymptote at pi over 2 plus pi k. The distance from the first one to the next one is a distance of pi. All right, so we got the tangents and cotangents done. Any question on the tangents and cotangents? Okay, let's go back and do the secant in number 3. What's the helper for secant? Cosine. So we know that this one minus pi goes which way?
To the right.
To the right. So we're going to start over here at pi. And we know cosine starts up. Oops, I went too many. It's up here. So ignore that one. Alright, so it starts up and then midline and then down. And then if I had more space, I would go midline and then I would go up again. But since I run out of room, what else could I do?
Go backwards.
Yeah, I go backwards. So I can go, oh, where did I go? I forgot to go down. Oh, down is right here. Okay. Yeah. So midline, down, midline, up. So I do have an asymptote at 3/2 pi and at 1/2 pi. Everywhere where the cosine hits 0, you have an asymptote. And then flip your curves. Okay, so your domain is everything except not your first asymptote. Plus, what's the distance between the asymptotes? Pi, good. So not pi. Pi over 2 plus pi k, those are the asymptotes. Okay, and then your range negative infinity to -1 and 1 to infinity. For number 3, it's x is not equal pi over 2 plus pi k. All right, so now we've been doing all these tricky graphs. Take a second and see if you remember how to do your sine graph in number 4. All right, moving on to the sine graph. -1 shifts it down. So you want to graph your new midline at -1. And make sure you label your x-axis. All right, and then sine starts on the midline, and then up, midline, down, midline. And we know it keeps going forever, so you could keep going backwards too. All right, so what's our domain for sine? Very good. Sine goes forever in both directions, so -infinity to infinity. And our range starts at what minimum value? For this one.
-1.
Well, that's in the middle. What's below that? Yeah, -2. So it starts at -2, and then it goes up to what maximum?
0.
Good. So -2 to 0. Okay. And then secant, your helper is cosine. This is probably the most complicated one in the whole packet. When I look at all of this, I always love to get rid of this +2 right away, because I know that goes up 2, so I'm just going to make my midline up 2 so I don't have to worry about it anymore. And then this 2 changes my period to what? What's the period secant? 2 pi. So you're going to do 2 pi over 2, which is what? Pi. So put pi right here. Pi over 2, pi over 4, 3 pi over 4. And we need to shift right pi. So when we shift right pi, I'm starting here, and I'm going to start 1 above. Now you could keep going if you really wanted to.
Did you do like pi 2, pi 3, pi 2, and 2 pi without the thing?
No, so because the period is pi, I put pi on the 4th line. And then I cut that in half. I put pi over 2 halfway, and then I put pi over 4 on the 1st line, and so my 3rd line is 3 pi over 4.
But how do you know the period is pi?
So you take the number in front of the x, and you do 2 pi divided by that number. 2 pi over b. All right, so I'm going to graph this cosine in pencil because I'm going to erase it. And then everywhere where the cosine hits the midline, I'm going to draw an asymptote. And then you want to flip the curves. And then finally, erase your cosine. You can draw more than one period if you want. I think on your homework it asks you to draw 2 periods if you have space for it. Alright, so the domain is a tricky one. It's going to be all real numbers. X does not equal, what's the first asymptote? Pi over 4. Plus, what's the distance from pi over 4 to 3 pi over 4? Subtract them. Pi over 2, yeah. So if you do 3 pi over 4 minus pi over 4, you get a distance of pi over 2. Okay. And then your range is -infinity up to what? 1. And then 3 to infinity. All right, so those are the 6 problems in the notes